Welcome everyone. Today I am going to demonstrate the star sequence alignment tool for next generation sequencing. So we can see that it is a pretty good sequence alignment tool with 39k of citation. So for that we have to go search star Bioinformatics tool. So here is the site. Let's check it. This is the official site, and you can see here is the source code from GitHub. Okay, now it is downloading, and okay, download complete. Let's check it. So here is the start tool. I already downloaded East Saccharomyces cerevisiae FASTA file of all genome and the cerevisiae GTF file. We need these two files to make the genome index. You can download these two files from this site, this FASTA file and the GTF file from here. Let's do it. First I have to extract this tool. Okay, done. Then check it. So to install this tool we have to go the source and open terminal here. Let's check the list, and so it is not executable. So for that we need to use make start in the source folder. So I'm pasting this here and enter. So now it is installing in my system. Okay, so it is done. Installation is done. You can see the list. So here you can see the star installed in my system. So I can just / capital ST here and press enter. It's showing that I can use start option, genome directory, and this. Okay, so let's see the whole manual. Just -h. Okay, it is a very long manual here. Okay, let's copy all and pasting here for use. So first, so we have the FASTA file and the GTF file of East genome. So first we have to make the index of the genome. So here I am creating one folder, and the folder name is genome directory. So first we produce the index in this directory. So the script is to generate the index. First I am /run mode genome generate, then come the genome directory. So this argument to generate the genome. Then we are going to put the genome directory, and it is home, then user, then in download, then genome directory, like this. Then come the genome FASTA file. Okay, something, let's clear it again, and okay, then I am pasting the genome FASTA file. So here we are going to add again home, Alex, download, and the FASTA file name. Let's see the FASTA file. This is the FASTA file. Let's copy it and paste it here. So there is genome, then we have to put the GTF file. So again, going to the path home, Alex, download, and the name of the GTF file. Just paste here, done. And the next argument is the overhang size and the run thread. Let's check it, and let's enter. So here we can see there is a warning sign. The genome is a index base 14 is too much large for the genome. Let it complete, then we'll check what happened. Okay, let's check the warning, this argument, and just copy. And what to do, we have to check in help section, control find and paste. Okay, in this parameter the must be scaled down to minimum. The 14 is default value and it is the log 2 of the genome length divided by 2 minus 1. Okay, let's copy. You have to calculate according to our genome. Here we can see the genome size of our yeast organism is this. Let's calculate it. So it is 2.5. So we can use only 2 for this argument. Let's do it again, and we have to put this argument here and it will be 2. Let's run it again. Okay, now there is no any warning sign. It's mean it is working fine and finished successfully. Let's check it. It is our genome directory. You can see several file was generated as the genome index. So it is the index file generation by the start tool using the genome Fastq and the GTF file. In our next video, I'll explain how to do the read alignment by the start tool with this genome index. You can try by your own or comment below for the alignment tutorial. I'll upload as soon as possible in response to your comment. Thank you.